All right, Algebra 1B, welcome to screencast lecture number 2. We're going to be continuing working in lesson 7-1, 0 and negative exponents. Let's open our books there to page 418. And just as a quick review of what we did in our last video on Friday, we talked about two properties that we're going to use for expressions with 0 as an exponent and a negative number as an exponent. So I have brought back these two example problems here, A and B, just as a review for you of what these properties say, right? We talked about letter B being easier because we had a property on page 418 that said anytime 0 is used as an exponent, as long as this number in here is not 0, your answer will be 1 all the time. So that's a reminder for you of that property. Letter A will remind you of the property that says if you have a number raised to an exponent that is a negative number, like that negative 2 right there, that's really the same as saying 1 over the same number raised to the same exponent but positive. So instead of 9 to the negative second, we're saying 1 over 9 to the second, and we know 9 to the second is 81, so 1 over 81. If you need to remind yourself of those properties and look at a few more examples, pause the video and look back here at page 418 at the bottom, and you will find those properties in those examples. But today, we're going to talk about how to turn this into algebra. And the way we're going to do that is to add in some variables, some letters, X's and Y's and B's and M's and N's and all kinds of other crazy things. Okay, so look at the next page with me, page 419. We're going to start in the middle towards the bottom, actually, with problem 2. And here's our main goal with this. Whenever we have an algebraic expression, we want all of the exponents to be positive. Okay? That is what we call, in algebra, the simplest form. Simplest. We always want our expressions to be in that simplest form, and part of that simplest form is to have all exponents be positive. Okay? So if we look here at problem 2, we are given some algebraic expressions that are not in simplest form, and hopefully we can see that the reason we know they're not in simplest form is because we see numerous negative exponents. All right, so let's take a look at letter A first here under problem 2. They are asking us what is the simplified form of this expression here. 5 times a to the third power times b to the negative second power. Now, most of that expression is okay. It is in simplest form. The part that's not, they have pointed out for you right there in red. It's the b with the negative 2 attached to it. Okay, negative 2 as an exponent. We need to deal with that and make sure that that has a positive exponent if we're going to call this the simplest form. Okay? So we know, based on the rule that we looked at on the last page and in the last video, that b to the negative 2 power is really the same as 1 over b to the positive 2 power, which we can see right there on the right side of that equal sign. 1 over b to the positive 2 instead of b to the negative 2 power. Now, when we simplify this, instead of saying 5 times a to the third times by that big parenthesis 1 over b to the second power, your book has just put b to the second power here on the bottom of a fraction with 5a to the third on the top. Let's talk for a quick second about why they did that. Okay? If we go back to 5a to the third times 1 over b to the second. I'm going to write that over here so I have a little more room to deal with. 1 over b to the second power. Okay? We know that 5/8 to the third, if I wanted to write it as a fraction, it makes no difference. I can put that over 1. Okay? Hopefully you agree with that. If that doesn't quite make sense to you, please make a note to ask me about that in class tomorrow. But 5/8 to the third divided by 1 is just the same thing. It doesn't change anything to do that. And now we're multiplying two fractions. And hopefully we remember how to multiply two fractions, but that's just as simple as multiplying the tops and multiplying the bottoms of each of those fractions. So we multiply across the top, 5a to the third times 1, that doesn't change anything. 5a to the third. On the bottom, 1 times b to the second, 1 times that thing is just going to be that thing. Timesing by 1 doesn't change anything, and now we have b to the second on the bottom. Okay? So hopefully we can understand now how they went from 5a to the third times 1 over b to the second to get our final answer over here. 5a to the third over b to the second power. Okay? Now, let's talk about what happens in letter B when we have a negative exponent that is already in the bottom of that fraction. Okay? Letter B wants us to write the, again, simplified form of this expression here, 1 over x to the negative fifth power. Okay? Now, 1 over x to the negative fifth power, you can see that your book has rewritten here, instead of the fraction bar, they have written a division symbol, right? 1 divided by x to the negative fifth power. That's the same thing. Now we use our rule, okay, because we know that x to the negative fifth power is really the same thing as 1 over x to the positive fifth power, okay? So now, if we look here at this step, here's what we have. 1 divided by 1 over x to the fifth power. Okay? Dividing by that fraction, 1 over x to the fifth power, hopefully we know that dividing by a fraction is the same as, right there, multiplying by the reciprocal. And reciprocal just means we flip the fraction over. So instead of 1 in the numerator and x to the fifth in the denominator, we're just going to do x to the fifth in the numerator and 1 in the denominator, or x to the fifth on top of the fraction, 1 on the bottom. Okay? So now what I'm really multiplying by, instead of dividing by 1 over x to the fifth, I'm now going to multiply by x to the fifth over 1, because that is the reciprocal. Instead of dividing by the fraction, I am multiplying by the reciprocal. Okay? 1 times that x to the fifth over 1. Well, 1 times x to the fifth doesn't change anything, and putting 1 on the bottom of the fraction doesn't change anything. So really all we have here is just x to the fifth. Okay? So hopefully you can see that if we have 1 over x to the negative fifth, when we go through all of these algebraic steps here, what we really do is still flip this expression that we have with the negative exponent to the other side of the fraction. It's in the bottom now, so we're going to flip it up to the top, x to the fifth, and now we change from a negative 5 exponent to a positive 5, and now our 1 is on the bottom. Okay? So, exponents that are negative that you see in the denominator or bottom of a fraction are going to flip up and become the top of that fraction. And if it was just a 1 that you saw over it, now the 1's on the bottom, which doesn't change anything, so we can just write x to the fifth. Either one of these two answers here would be fine with me. Okay? Now, please feel free, if you need to go back through any part of that explanation for either part A or part B, feel free to go back in the video, look at it again. When you think you've got it, take a look at these 3 problems right here. I want you to make sure you can do those 3 problems. I'm going to go through the answers to the first and second and just show you real quick how those will work. then you can do C, D, and E, and then move on, okay? So letter A wants us to write, again, the simplified form of this expression, x to the negative 9th. We know that x to the negative 9th is the same thing as 1 over x to the positive 9th, okay? And this one is no more complicated than that. There's nothing else in that expression, so we are done right there, okay? Now, letter B is just like this letter B that we looked at right up here. 1 over n to the negative 3rd power. So our rule and all this algebra that we did up there told us that 1 over n to the negative 3rd should flip over and become now n to the positive 3rd over 1 instead. And we know that n to the 3rd over 1 is just equal to n to the 3rd. Okay? If neither of those or one of those two examples doesn't make sense, please make a note to ask me in class tomorrow, and then go ahead and look at those 3 problems there. Make sure that you can do it. So pause the video, look at those 3 problems. When you're ready, go with me onto the next page for problem 3. Okay, just a couple more examples before you get to your problem set. Okay. Once we're comfortable with moving around all these variables, these x's, y's, n's, a's, and b's, and things like that with our negative exponents, now we are going to plug in numbers into those unsimplified expressions, okay? We are going to be asked to evaluate an expression, okay? And that just means plug in numbers that the book will give you for certain variables that you see in the expression, okay? So problem 3 says, what is the value of 3s to the 3rd power times t to the negative 2nd power for this value of s equals 2, and this value of t equals a negative 3, okay? 2 choices here. One of them is going to look a lot like what we did yesterday in example problem 1, back on the top of page 419. The other is going to look a lot like what we just did earlier in this video on page 419 at the bottom in example problem 2. I'm going to go through method 1 because that's what this video is all about. If you want help with method 2, take a look at what your book is doing and possibly go back to that other video. But I think method 1 is the better choice here, so that's what we're going to do, okay? This one says simplify first. That means do exactly what we just did on the previous slide, and then plug the numbers into whatever you have that's simplified, okay? So we are given 3s to the 3rd times t to the negative 2nd. The only part that we need to deal with is that part there, the t to the negative 2nd. Everything else is perfectly fine. But we need that negative 2 exponent to become a positive exponent, so we know that it needs to become the bottom of the fraction, okay? So I'm going to put it on the bottom of the fraction. Instead of being up there with the 3s to the 3rd, now I'm going to put it underneath the 3s to the 3rd right there. And now instead of a negative 2 exponent, I'm going to put a positive 2 exponent, okay? Once I have that simplified, all my exponents are positive, 3s to the 3rd power over fraction bar t to the 2nd power. Now, I will plug in my 2 numbers. So everywhere that I saw an s, I am now going to put a 2. And everywhere that I saw a t, I am now going to put a negative 3. So now my equation, or excuse me, my expression has become 3 times 2 to the 3rd power over fraction bar negative 3 to the 2nd power. Okay? This is that exponent practice that we did at the beginning of the last lesson, those warm-up problems. Hopefully you can find on your calculator that 2 to the 3rd is 8. 3 times 8 over negative 3 to the 2nd power should be a positive 9. Negative 3 times negative 3 makes it positive. 3 times 8 then gives us 24 over 9, and if we make that into a mixed number, it's 2 2/3. Okay? I would take either one of those answers. This one here, I would like to be simplified on the left. The left answer I would like simplified, the right answer is wonderful. You can see that that is exactly what they got doing method 2, where they plugged the numbers in first and then simplified, making their exponents positive. Either way you want to do it is fine with me. Okay? When you think you understand the process of that method 1, simplifying first and then plugging in numbers, go ahead and take a look here at A and B, letter A and letter B, and I want you to find me the value when n is equal to -2 and w is equal to a positive 5. So pause the video, take a look here at letter A and letter B, make sure you understand those, and then come back with me and we will summarize what is happening here and finish out this video. Okay? I'm going to skip the science class example for the sake of time, and we're going to go here to our summary. This is something to add to your notes, okay? Please, please, please add these 4 steps to your notes. Add to notes. All right. When you simplify expressions with negative exponents, here's the 4 steps I want you to go through, okay? First one should be easy. Find the number or variable that has a negative exponent in it. That's the one that we are worried about. Anything with a positive exponent is perfectly fine and can stay where it is. Okay? Decide then if that number or variable is in the numerator, meaning top of the fraction, or denominator, meaning bottom of the fraction. Okay? If there is no fraction bar, everything is in the numerator. Please, please, please remember this. If you don't see a fraction bar, that means everything is on the top. Okay? And whatever's negative should go to the bottom. And that is step 3. Switch the location of the part that has the negative exponent. If it's in the denominator, meaning the bottom, it goes to the numerator or the top. And the other way around, if it's in the top, it goes to the bottom. Okay? And then the last step is also, please remember to switch the exponent from a negative number to a positive number. Don't rewrite your negative exponents after you have done your switching. Okay? Add those 4 steps to your notes. Those 4 steps should prepare you very well to start then your practice problem set. So pause the video, add these 4 steps to your notes, then you can start your practice problem set, which is right there. If you have any questions, please, please, please ask me in class tomorrow. I will see you then. Have a spectacular night.